Okay, so now moving on to discuss this line right here. Oops. Just as a reminder, we are on section 2.1 of the famous paper by Nelder and Wedderburn. The link to this paper and the complete playlist will be provided in the description of this video. Okay, so what are we doing right now? We've defined W as a weight function, and then we said equation 7, which is up here, will yield this equation. Okay, so where we have this W. Now you might be wondering, why are we doing that? It leads to some just notational convenience later on, and so that's why we're doing it. Okay, so you see that basically this piece here, so W is basically this piece right here that's in the Fisher information matrix that we discussed in the previous video. Okay, so let's go ahead and go to our Blackboard, and this is what we want to show right here. I went ahead and wrote the expected second derivative just so that you can see that this W here is basically just this piece right here. So the expected second derivative can also be written as alpha of phi times W times xi xj. Okay, and that's really convenient, and that does get used in the next section. Okay, similarly right here, it's a little bit more complicated. We have the first derivative. This is what we want to show. Just this, and this is equation 7 right here. Now, I've marked a few things in blue, so what's going on right there? There was a typo in the paper. They had alpha of, if you go to equation 7, they have alpha of theta. Should have been phi. That was just a small typo. Another thing is, in this weight function, they have d lowercase y. It should be an uppercase y. And you might ask yourself, why? Do I care? Well, because later they're using another definition for lowercase y's. So we need to be maybe a little careful with our notation just to make sure that we understand that this is exactly the same as this y right here. Okay? So I just marked it in blue right there and here just as a reminder that there's small typos in the paper. We all make them, including myself. Probably in every video I make at least 1 or 2 typos if you look closely. I'm sure you could find them. It's impossible not to make really small ones like that. So, okay, so let's see. I want to go ahead and start here. And what I want to do is I want to rearrange this so that I can have something that looks like a W. All right, it's a little forced, but it's not too hard. Okay, so I have alpha of phi. I'll take this z minus mu. I'm going to put that xi a little bit closer here. So I'm just kind of rearranging things at this point. I have d mu dy, okay? And I have that divided by v. So I've done nothing at this point other than rearrange my products and my division, okay? I'm trying to make it look a little bit more like this. All right. Now what I'm going to do is I'm going to multiply this by d mu dy divided by d mu dy. Okay. Now that's the same thing divided by itself, so it's 1. So I haven't done anything other than something that's nice for notation. Okay. So let me go ahead and rewrite this one more time. All right. I have this in the numerator and this in the numerator. That's the same thing as d mu dy squared. Okay? So look at what's in the top of my fraction. This and this. Okay? And then in the bottom, in the denominator, I have v. Okay? And then I'm going to, instead of putting d mu dy, I could put it on the bottom of this fraction right here, but I also could just write this as 1 over d mu dy. Okay, so basically it's in the bottom of the fraction. The reason I wanted to write it like this is because then I can see that this is exactly w. This is w. Okay. So this equals, all right. If I just want to rearrange my products, I could, because I want it to match what's up here, I have W, Xi, Z minus mu. Okay, and then I have this basically multiplied by 1 over this. So basically that's the same thing as dividing this by d mu dy, right? It's in the bottom of a fraction. All right, so I see that's exactly what I wanted it to see. So I've shown that this is true. Okay, just using a little bit of algebraic manipulation, I can get there.